So the next topic in this particular unit will be the last unit for electrostatics. The name of the topic is Van de Graaff generator. Van de Graaff generator. As the name suggests, it is a generator which is going to generate high potential difference, which may be of the order of a million volt. Right? See, a Van de Graaff generator is used to generate high potential difference. It may be of the order of 10 power 3 to 10 power 6 volt. This much amount of large potential can be generated by a Van de Graaff generator, and this much large potential which is produced by this device can be used to accelerate positive charges. This is the positive charge or negative charge depending on the situation. So it can be, this high potential can be used to accelerate the charged particles, either it may be electron or protons or neutrons, etc. So this Van de Graaff generator, the basic idea behind a Van de Graaff generator, let us see the basic components here. See, you will have, in order to explain the principle, see, you have a spherical cell, metallic spherical cell like this, supported by an insulator column, and you keep another smaller cell here. The radius of the inner cell, this is small r, and the radius of the outer cell, this is capital R. Then these two cells are connected, metallic cells are connected. You can use a switch here. If they are connected, initially this inner cell should be charged by an amount of charge, say, let us say Q. Then how much will be the potential at the center? Then potential at the center, due to the inner potential, inner cell Vi, let us say, this will be K Q divided by R. Okay. Then how much is the potential at the center due to the outer cell? Then this will be how much? VO, let me say, K Q divided by R. Right. Then which potential should be larger? Which potential should be larger at the center, Vi or VO? Obviously Vi will be larger because this inner cell is nearer to the center. So if you want to find the potential difference, this will be, difference means the subtraction of these two values. This will be Vi minus VO. Okay. This charge Q should be the same. Then this will be how much? Q can be taken common. What is K? K is Coulomb's constant. Then this will be 1 by R minus 1 by R2. 1 by R minus 1 by R. Small r minus capital R. There you go. Then let us focus on this last expression. Last expression, V here. See, as you see from the figure, if you make the size of the two spherical cells very differently, that means when R is very much greater than small r, this difference will be very large. Right? So if you make the difference between this small r and capital R to be very large, then obviously very high potential difference would be generated. This is how the basic principle is working behind a Van de Graaff generator. How much large potential can be generated depends on the radius of these two spherical cells. Right? See, if you make the difference of this capital R and small r very large, then obviously this potential will be, potential difference, very high amount of potential difference will be generated. So this is the basic principle behind the Van de Graaff generator. Then let us come to the exact device to kari yaugani haiba kanda. There will be the spherical cell, the inner, outer and the inner will be simply here. Let us see how it is used to accelerate the charged particles. And this spherical cell is supported by two insulator columns like this. Let us remove this part. These are the insulator columns. Let us say C1, C2 are insulator columns. S is the spherical cell. Let us say S here. Then within this cell, you have just at the base you have a high tension supply, high voltage supply. Then you connect it to the positive terminal, and you have a comb like structure here. Let us say this is a spray comb. If it is connected to the positive terminal of the HT source, some charged particle will be induced here, positive charges, if it is connected to the positive terminal. And this principle here is known as corona discharge. Corona discharge. This is the first principle, corona discharge. The activity which is being taken place here, this is known as corona discharge. When the sharp end of the metallic surface is connected to the positive terminal, the air molecules here will get ionized. That is known as corona discharge. Then when you have these positive charges, let us have a rotating bell like this. Rotating bell. See, the pulleys are rotating like this. As the pulley rotates, these stars accumulated here will be moving upward like this. And just near this other end, upper end, let us connect another comb. Due to the principle of induction of charge, opposite charge will be induced here, and the same opposite charge will be induced on the outer surface of the cell. So if you go on increasing the potential, more charges will be accumulated on the outer surface of the cell. Alright? Then this will be on the base. And these accelerated charges, when you increase the potential, the charge will go on accumulated. When the charge is saturated over the sphere, the extra charge will be incident on the ion source within the discharge tube. Discharge tube will be here. Discharge tube will be here. Ion source, when it is incident by the charge here, accelerated charge here, it will get ionized and the ion will be emitted here. This emitted ion will be accelerated and incident on the target. Right. So this is the basic idea behind the Van de Graaff generator. See, the positive charges will be produced by corona discharge, and the second principle is uniform distribution. Uniform distribution of charge. Distribution of charge on the surface of the hollow matter. This is the second principle. So let me remind you how to accelerate the charge. The high potential which is produced will be connected to the one of the combs. Then it will produce charge particles due to corona discharge. This charge will move upward, induce charge here, again here. Then when the charge is saturated over this sphere, the extra charge will be incident on the ion source inside the discharge tube. The ion source will produce accelerated ions and incident on the metal. Right. This is the working as well as the construction of the Van de Graaff generator. Okay. For sake of safety, it will be enclosed by a steel case. Right, and this is the basic principle and working behind the 1D Graaff generator. And this principle and to draw the diagram, this is somewhat important for your examination point of view.